Hello, good morning everybody. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good morning to you all. I would like to wish you all a happy new year and thank you for taking your time out to participate in today's session of our series of DigiBiz Talk webinar. It's a great pleasure for the Authority for Info Communications Technology Industry of Brunei Darussalam, AITI, to welcome you to the seminar on immersive technology into enterprise. Ladies and gentlemen, DigiBiz Talk is one of the initiatives by AITI to encourage ICTs and digital adoption in the country, particularly to support the growth of businesses through a series of seminars related to emerging technologies. Today's seminars aim to promote the opportunities to introduce immersive technology into the enterprise. It is to create insights based on immersive technologies and look at business reasons for wanting to make use of this new area of technology. Immersive technology is an integration of virtual content with a physical environment in a way that allows the user to engage naturally with the blended reality. One of its trending realities in immersive technology is virtual reality. Virtual reality is a simulated experience that can be similar to or completely different from the real world. Applications include virtual reality that includes entertainment purposes. Virtual reality's roots lie in a combination of 3D stills, image, computer gaming, computer-assisted instructions, and also equipment simulators. Another is augmented reality, which is also called AR. It's the technology that expands our physical world, adding layers of digital information onto it. AR itself can be displayed on various devices, especially screens, glasses, handheld devices, mobile phones, head-mounted displays. Many modern devices already support this kind of technologies. From smartphone and tablets to gadgets like Microsoft HoloLens or handheld devices, this technology continues to evolve. Ladies and gentlemen, to have a better understanding on the introduction of immersive technology in the enterprise, in this session, we will have invited a moderator and regional experts, speakers in the field of immersive technology. Before I end, I would like to thank Recap for facilitating this webinar. I wish everyone an enjoyable and a very informative session. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you very much.
Thank you, Yang Mulia Muhammad Nur Ilham, for your speech. Finally, I would like to extend a very warm welcome to our esteemed speakers, Shawn Beck, who is joining us today all the way from Malaysia, alongside Teck Lee Tan, all the way from Singapore. More about their introduction will be covered by Antovany Reza Pahlevi, who will be our moderator for today. So our moderator comes from Jakarta, Indonesia, and Antovany is currently the Chief Investment Officer of Shinta VR, Indonesia's first virtual reality company. He is also an immersive technology practitioner and has been serving 6 in Southeast Asian countries, for example, Singapore, Malaysia, Indonesia, Vietnam, Cambodia, and the Philippines. When he was in Silver Sea Media Group, a Singapore-based immersive media company, as regional head of marketing. From various technology background and experiences, ranging from global internet company to emerging startup industries, Antovany has a strong belief that immersive technology and the Metaverse industry will play significant roles in the present and near future. The spotlight is yours, Antovany.
Thank you, Tia. So, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. It's a very great pleasure here. We can discuss about the topic today, introducing immersive technology into enterprise. So for long story short, I've been experiencing or exposing with this immersive technology since I working in Singapore in 2019, I think. And during this, say 2 or 3 years, we've been seeing a lot of changing that now we know that the world getting closer to the world of Meta since Facebook changing into Meta. So today we will talk and discuss with these 2 wonderful gentlemen from Unity. So actually Unity technology is I think so far is the most well-known game engine for, let's say, for the gaming itself, or VR development or AR development. And we will welcome our first speaker here. I will give shout out to Mr. Shawn Beck from Unity Singapore or Malaysia, I think. Unity Malaysia. Hi, Mr. Shawn.
Hi, morning.
How are you?
I'm doing good. Thank you. Thanks for asking. Hope you're all well.
Okay, so I just got your profile from Recap that you are very expert in the programming, game programming, sound design, some of the production art, and maybe I want to know more about you, especially from your past experience and also now when you're working with Unity. And I think today, for the first speaker, we will dive more into AR, right? Augmented reality. I think me as a non-tech background person, I think I can help people to getting to know the fundamental or basic knowledge about this technology. So I think I will give you time and place to start your presentation, Mr. Shawn. So the time is yours.
Okay, thank you. Hello, everyone. My name is Shawn. I am a field engineer from Unity Technologies. Right, joining me today is my colleague Teck. Thank you for having me today. And the topic for today is augmented reality. This is really an introduction to AR, what it is, and what are some cool things it can do. So I'll also do a short introduction to Unity Technologies as a whole. Unity is the world's leading platform for creating and operating interactive real-time 3D content. Our platform provides a comprehensive set of software solutions to create and operate content for mobile phones, tablets, PCs, consoles, and augmented and virtual devices. At Unity, we believe the world is a better place with more creators in it. This philosophy is centered around serving creators, and it is the beating heart of our company. This motivates each and every one of us to help solve the toughest engineering, data, and operational problems so that digital creators such as yourself can create and operate. Well, first, it's important to also realize how much the world has changed. What started in gaming has exploded. 5 years ago, we saw industries just scratching the surface of what's possible using real-time 3D. Specifically, we saw that many industries were still yet to create tools that were conceived and built back in the 90s or the 2000s, before the explosive growth of compute power in personal devices we all now carry with us in our pockets. And the network of computers that live in the cloud, adding to more processing capability. Creativity and technology is converging, and it's spawning unlimited opportunities in every industry imaginable. And this is where real-time 3D, or as we call it in Unity, RT3D comes in. So Unity is leading the way to the future, and games, as you know it, are mostly 3D. They are real-time and they are interactive, meaning that unlike in a movie, a character or an object in fully 3D can be inspected in full 3D, meaning that not only that we can see the front, but we can also move around and view the character from other sides. Real time means that the next frame the player sees is created in an instant, a 30th of a second, or sometimes 60 or 120th of a second in some virtual reality platforms. In other media like TV and on the web, most content is fixed and unchanging. Interactive means that the game changes in response to the input of the players. The content is dynamic and responsive, and Unity is the leading platform for creating and operating this type of media. The Unity game engine is a comprehensive real-time 3D platform, and we give everyone and anyone around the world the tools and technology to create and the solution to operate so that they can succeed in the real world, with Unity Runtime Engine being the connective tissue that brings the platforms together. So anyone can use Unity to create world-class tools, using world-class tools and workflows. We provide solutions for brand new creators just getting started and advanced developers striving to create AAA fidelity games or experiences. As you all know, Unity is a company born from gaming. our create tools are responsible for some of the world's most popular games, we're proud to say that King released its first title built solely in Unity in March 2021. And they are the makers of Candy Crush. King has released the latest in Crash Bandicoot franchise, Crash Bandicoot On the Run, built entirely on Unity. As its first 3D mobile title, King's highly ambitious goal demanded that they be intentional about choosing the game engine. So they chose Unity to bring their beloved franchise to mobile with console quality graphics and playable on a broad array of devices. And we're also proud to say that games made with Unity accounted for 71% of the top 1,000 mobile games in Q4 of 2020. Also, half the games made in Switch are made in Unity. We also work closely with developers to bring their creations to life on Nintendo Switch. To date, half of the Switch titles are made within Unity, and those include titles such as Kingdom Hearts, Melody of Memory, Ori, The Will of the Wisp, and MiHoYo's Genshin Impact. But as we know, real-time 3D tools have applications outside of gaming, and our efforts beyond gaming are also gaining momentum. Our customers are turning to Unity to help them create and build everything from in RT3D, from the next generation office buildings to self-driving cars to video games enjoyed by millions of people around the world. Building on Unity means you're not tied to one single platform. Anything you build today can be redeployed to another platform. Today, we support more than 20 platforms and counting. This flexibility extends to our approach to the many augmented reality SDKs. Whether you're developing on Android or iOS, building an augmented reality experience today involves just developing once and deploying for all. So let's begin talking about augmented reality. We'll be talking about AR and its many disambiguations, specifically around the many variations. What is XR, AR, MR, and VR? I'm sure you've heard a lot of these terms thrown around, but there's always some confusion as to what they stand for. So first of all, XR stands for extended reality. What it is a catch-all term for all experiences that enhance our view of the world, which means whatever you see in the preceding slides, AR, MR, VR, they fall under XR. Then we have augmented reality, AR. And AR is just as simple as overlaying computer graphics information or CG information over real-world view. It could be a simple label of what an object is, or a 3D character posing as a virtual figurine on your desktop. Any piece of virtual asset superimposed on our view of reality is an AR experience. Taking it one level further is mixed reality, or MR. So MR blends CG objects seamlessly into our real world and interacts with dynamic changes in our world in real time. Imagine placing a virtual glass bottle on the table and having your cat obliviously walk through it, pushing the virtual glass to the edge of the table and eventually tipping it over, falling to the ground, shatter into 1,000 pieces all over your floor. Not the most exciting scenario, but it shows how the virtual world and the real world are slowly converging into a more complex and immersive experience. Virtual reality is one that's easy to grasp and something that Tech will be covering in the second session. It's basically replacing the view of the user and fully immerses them into a virtual 3D environment. So here's a simple but useful example of augmented reality. Information is overlaid on top of a real-world view, but it does not interact with the environment. Here we see the user can scan an image which identifies the server rack, which, thanks to its relative fixed position from its ports, can serve as an anchor point for superimposing useful information over the ports of the rack. All right, see that again. You can see the ports are overlaid top, and it just simplifies instead of having stickers labeling what those ports are, you could even add on additional information of what those ports, the purpose of those ports and how you should work around them. In mixed reality, your computer-generated information interacts and responds in real time to changes, and sometimes blends seamlessly with reality. This Huawei HUD heads-up display enables safer assistant driving in the driver's view by providing useful information to help our drivers of tomorrow, you and me, make more informed and better decisions on the road. And virtual reality immerses users in a different world, oftentimes tricking our senses into perceiving the virtual world as the real deal. Here, users experience a natural fear of heights in a digital experience. I think Teck will talk more about this in the second session. But as you can see, this is a very powerful tool that elicits various types of emotions in the situations that you put them in. Although it's not real, people feel actual fear of falling, trying to play Richie's plank experience. Okay, and Unity also provides powerful tools to make rich and deeply engaging augmented reality experiences that can intelligently interact with the real world. Let's take a look at what AR can enable us to achieve. So I'll just play this little clip. Right, so it's a little sizzle reel of what Unity is capable of in AR space. So I'd like to approach this from a tools perspective of what Unity can offer and see how it can empower you to shape our new virtual worlds. So today I'll be talking about 4 tools, some just touched upon lightly, on how they can bring your creative visions to life and what you can expect to implement in your AR experiences to take them to the next level. So starting with AR Foundations. AR Foundations is a framework purpose-built for AR development that allows you to develop your app once and then deploy it to multiple mobile devices or wearable AR devices. And then we have Unity Mars. Unity Mars provides AR creators across the industries with specialized tools and streamlined workflows to create AR experiences that intelligently interact with the real world. The XR Interaction Toolkit, or XRTK, adds interactivity to your AR apps by simply dropping components into your scene. So it's no more coding these object interactions from scratch. Although you can, it simplifies having to build interactive interaction tools within your AR or VR experiences. And then finally, we have Unity as a library, which allows you to insert AR-powered by Unity directly into your existing native mobile app. So let's start with AR Foundations. So AR Foundations, as mentioned, is a framework that allows you to leverage the core features from Airkit, AR Core, Magic Leap, and HoloLens. So Airkit is the AR SDK on iOS, on Apple devices, and then AR Core is the Android equivalent. And this builds on top of the same principles of develop once and deploy to all platforms, all in one single unified workflow. So we built AR Foundations to make it easier for you to deploy across multiple mobile and wearable augmented reality platforms. AR Foundations is our core AR framework, specifically designed for enabling multi-platform AR experiences. Data is fed to the AR Foundation through packages that are built on top of each SDK. So no matter what device you're targeting, once you've built your app using AR Foundations, it can take advantage of all the supported features for all platforms. The AR foundation layer receives data through subsystems in different SDKs and allows you as the developer to focus on developing the app. So even if one feature is enabled on one platform, but not on the another, we put hooks behind the scenes so that it will be ready to go later. When a certain feature becomes enabled on a new platform, you can easily integrate it by updating your packages. You don't have to completely rebuild your app from scratch. Here you can see some features such as 3D body tracking isn't available in AR core or Android devices. Once that feature is supported on that SDK, integration is just as easy as updating the AR Foundations package, rebuild it, and you're ready to go. So let's look at a couple of AR Foundations features in action. Here I'll be showing you some examples from these two repositories here, the AR Foundation samples and demos. And if you have the time, I highly encourage you guys to visit these links and check them out. I will also leave these links at the end of the presentation so you can follow through on it. So first of all, the most common use case of any AR app is, well, the main feature that you will probably be using is tracking the plane or flat surface to place your AR, your CG object on top of it. Right? So this is the most standard feature of any AR SDK is plane tracking. This basically just allows you to identify surfaces to anchor your digital assets. Right? So it can be a wall or it can be just the floor. And combine that with some real shader wizardry, you can unlock some unique experiences like never before, such as this sink or wormhole on the ground. You can also use image tracking to track multiple unique images, and in turn, having that both interact and spawn unique objects for each of them. This is done as easily as importing an image into Unity. And then you define physical size estimate, and determine what sort of objects you want to anchor to the image. And then Unity will take care of the rest. It's as easy as putting in an image, creating an object in 3D, and then associating it with that image inside Unity. You can even scan physical objects from the real world. Here's an example of capturing an object's feature points. This is a video taken by a colleague of ours, Marek. So here's an example of capturing object feature points using the Airkit companion tool. So the Airkit comes with a companion scanning app that allows you to capture feature points of an object that you can later export and then re-import into Unity for Unity to recognize it in your application. On LiDAR-enabled devices, such as the iPhone Pro series or the iPad Pro, you'll be able to track and track the pose of a person and map that information to a character, or attach virtual objects to the subject and more. So a lot of people also use AR as a cheap alternative way to do motion tracking or to capture performances of an actor. Right, so this also works for faces. You can also track faces and eye direction, and this information fed back into Unity from the Airkit or AR Core SDK, and then map to a specific blend shape ID on the mesh, allowing you to create 3D head replacements like what you see here. Because eye tracking is also supported, you can move the model's eyeballs based on your gaze alone, or even anchor laser beams to stream out of your eyes. To further enhance the experience and blend into reality, both AR Core and Airkit support light estimation. The subsystem analyzes images from the camera, providing detailed information about the lighting in your scene. And you can use this information when rendering virtual objects to light them under the same conditions as the scene they're in. So it more matches the environment that you are using experience in. Furthermore, environment probes capture real-world imagery from the camera as you slowly move your camera around, and then converts that information to a texture that contains the view in all directions. Rendering 3D objects using this environment texture allows for real-world environments to be reflected on your rendered objects, such as what you see here. The result is a realistic reflection and lighting of virtual objects, which enhances the appearance of rendered objects and allows them to better match the real-world environment again. So I'll also pick up some advanced demos from the AR Foundation demos repository. If you're interested in getting started with AR Foundations, there is a repository. This is the repository featuring some of the advanced demos of what AR Foundations is capable of. And we'll be taking a look of some of the more interesting implementations in the following slides. So available in Airkit 3.5 or AR Foundations 4 on iOS devices with LiDAR sensors, there's a feature called meshing. And meshing can provide classification for different types of surfaces, such as ceilings, doors, floors, seat, table, walls, and windows. Here you can see the contextual items available to place on the surfaces change based on the real-world surface that you hover over. And so the three icons at the bottom, you can see them change as you hover over different parts of the environment. The floor is recognized as a floor, the wall is recognized as a wall, and we spawn different objects based on that. And so iOS provides this classification of your real-world environment for you. So you can see here, this is a visualization of that as well. They are color-coded. Each classification is color-coded in this image, showing you the differentiation between the floor, table, sofa, and walls. Because AR is basically just superimposing CG imagery on top of real-world images, it's hardly realistic to have a 3D object not be occluded or hidden, by a random passerby walking in front of your object, or it never disappearing from your sight when you walk behind a wall. For this reason, many occlusion methods have been introduced to create an effect to further ground our CG objects in the real world. So one such feature is the simple planar occlusion, as you can see here. So planar occlusions, as we hover our view over the table, which is play this, obscuring our 3D objects from our view, it slowly gets partially occluded until it disappears from our view. Just as as we expected it to happen in real life. It's not just a 2D image superimposed on top of another 2D image. Right, let's see that again. It's hidden behind the table. Okay, we also have people occlusion, right? So AR Foundations also supports people occlusion. That includes hands as well. So you can see the hands actually is capable of hiding 3D objects behind you. And then there's also depth occlusion. And if you have a LiDAR-enabled device like iOS or like the iPad Pro or the iPhone Pro series, right? It constantly generates like a depth map from your LiDAR sensor. And this depth map allows automatic occlusion, thanks to the depth map it generates. It allows us to hide our CG objects behind dynamic moving objects in the world. So you can see this drone here. It's hidden behind this pole. There's also a longer video of this drone actually hidden by the cars that's passing by. And with a depth map from your LiDAR sensor, you can use that depth map to also create a virtual fog experience. So here, using the same depth API, again, only available on LiDAR-enabled iOS devices on the iPad Pro, we can create cool effects like this fog to further enhance the experience. So we've talked about occlusions using our depth map and relying on planar mesh. So there's two different methods. What we could also do is using meshing from earlier to act as an occluder as well to hide our objects. So there are some pros and cons to either methods. Meshing works well with static, non-moving objects, while drawing more heat and is mostly only compatible with iOS devices with LiDAR. Whereas depth map base occlusion works better for dynamic environments and is supported on iOS and selected Android devices that support generating depth maps from their cameras. So one's better for static environments, while the other, the depth map, it's much better for dynamic environments that's always changing. So we've talked about light estimation, but without shadows, light without shadows, 3D objects will often feel like it's floating above the surfaces. So to enhance the realism and believability of virtual balls sitting in our furniture, we can use soft shadows on our AR apps to enhance this. Hard shadows are also supported. These examples are from the demo repository that you can check out. And you can try both of them. Additionally, camera grain is a unique feature to Airkit, which produces tileable metal textures to match the visual characteristics of your current video stream. As you know, when you take a picture, it's not perfect, especially in low light conditions. You might see some camera grain or some fuzziness in your images. And that's not usually the same for 3D CG imagery, right? They're always smooth surfaces with no imperfections. And that can look kind of jarring. And in Unity, this is surfaced as a 3D green texture through the AR camera frame event. For shader samples, this green texture is then sampled. This is applied to custom shaders in the shader graph and creates that visual noise on the object. This effect is generally very subtle. It's more visible in darker areas where green on the camera feed is more apparent. So this feature is only available for version 2020.2 and above for Unity. And this is due to how the 3D textures are handled and managed. The demo repository also contains templated instructional UI because AR is relatively new to a lot of users. So most users are lost when they try their first AR experience. For this reason, we've developed an onboarding UX kit or user experience kit to help ease users into an AR experience. This template consists of the following animations and videos, helping them to find a plane on the ground, a flat surface, finding a face, finding a body, finding an image, finding an object, or just coach them to how to use the AR experience. And it's usually goal-based with a cue. So it would kind of coach them to complete certain tasks, like find a surface or move your camera around just to test and check your environment. So the instructional UI also helps inform the users if there's an error on their part in setting up the suitable environment or the conditions. Maybe there's not enough lighting or it's being obscured. Those things are there to help onboard your users, to help them understand how to use an AR experience more intuitively. The UI in the app can also be localized within Unity itself. So if you're operating in a different language, this can always be changed. So after all that, we're ready to decide what features we need in our AR apps. So let's look at some use cases. And of course, back in 2016, Pokemon Go demonstrated the mass appeal of handheld AR with its massive popularity. I still remember the first day the game launched. Thousands of people in Kuala Lumpur of all ages, gender, and ethnicity poured into the city, holding up their phones all over void spaces, catching virtual oddities. And I remember I was in the city that day, and it was quite a magical experience. Everyone doing this exact same thing, thousands of them in a mall. And like Pokemon Go, Angry Birds found a way to breathe new life into the franchise using Magic Leap. Let's take a look at a short clip of this. Right? It's still the same Angry Birds experience, but brought to augmented reality. And you gain like a brand new perspective in your game by being able to just view your environment, view it in your environment and see the game space interacting with your floor and tables. And also for construction professionals, they can visualize designs and collaborate in real time by overlaying large BIM or CAD files onto job sites using AR. So Visual Live is a Unity solution for enabling AEC industries to reduce costs and increase efficiencies by visualizing and collaborating in augmented reality. So this lets multiple users work together in real time in the same space and seeing the same AR experience overlaid on top of their real world environment. Okay. WannaKicks is a mobile app that lets you try out of what works best for you. And in your space at home. It makes buying decisions, lets you make buying decisions in your own place to get inspired and try many different products and styles. Let's take a look at this clip of IKEA, please.
IKEA would like everyone to know about Place, our new augmented reality app. Built on Apple's new Airkit, you can easily place true to scale 3D models of IKEA furniture in your place. Scan, browse, select, move, and place. So that could mean less of this. And less of this. And probably more of this. We want to make it easier for people everywhere to imagine a better place. Share this place and this place. Try place in your place. Hey!
These AR experiences have proven to deliver return on investment. And at a recent trade show, one booth actually recorded 35% more leads as a result of on-site real-time activations using AR experiences such as what you're seeing on screen right now. And building on top of AR foundations, we also have a tool or framework called Unity Mars. Unity Mars offers a feature-rich toolset to help make AR experiences more enjoyable to develop. So Mars is an authoring environment to help you more quickly create AR experiences that are flexible, customizable, and works across locations and data types. And this builds on top of AR Foundations framework, as you can see. Let's take a look at what Mars is about.
What's Unity Mars? Well, certainly not the planet, but it really knows this world. Unity Mars gives you everything you need to create powerful mixed and augmented reality experiences that interact intelligently with the real world at any location and with any type of data. Need to visualize a place or product, create a unique experience for an event, train up your staff? No problem. Imagine the possibilities as you author for games, sales, marketing, and more for any device or hardware platform. With Unity Mars, you can quickly capture and assemble real-world assets like locations, objects, and props. Then, just drag and drop them and test on the fly, all without leaving the Unity editor. Unity Mars experiences are powerful, interactive, and intelligent. Build once and deploy on any AR-enabled device. Get Unity Mars now and shape the world.
Okay, so Mars allows you to author AR apps more visually, allows you to also test your AR experiences directly from your Unity editor without having to leave your screen. Because of the nature of AR, you actually need like a camera to use it. So normally you deploy it to your devices, like your iPhone or your Android device, because you need to leverage the SDKs of Airkit and Aircore. And with Unity Mars allows you to actually simulate that virtual space inside your editor instead of having to deploy it out all the time just to test. So it also works with unknown elements like fuzzy authoring and proxies to place stricter and more flexible conditions for how your AR content exists in the world. So to understand more about how Mars is critical to the experience, let's look at some AR development challenges. Now, first of which is authoring complex data-oriented apps visually. Realistically, it's impossible to know exactly where someone will use your AR app and what physical objects will be in their environment. So even if you're building for a specific or controlled environment, for example, a museum, floor plans and installation locations can change. And people viewing the AR experiences may do so from different viewing angles, and they could be of varying heights. And possible variables and their combination could be nearly infinite. It's nearly impossible to define manually when creating your app. So added to the tedious task of coding the dimensions by hand, you could spend a lifetime coding and still not have accounted for every possible variable. So next is being able to test your experiences in a painful and efficient way. It's highly likely that your physical space when you're developing your app won't be the same as the users when they're running it. You're probably developing in your office space, but you need maybe a living room or kitchen environment to test it. You can't teleport yourself to Tokyo if you're building a location-based environment experience for the airport yet. Right? For geolocation games, it's simply not feasible to test your app in every outdoor environment around the world where your app will be used. And this common pain point across development cycles. This is a common pain point across development cycles when you're building a mobile experience. So it's time consuming to also wait for build and test it on each device you want to work on. And then lastly, testing experiences. Sorry, missed my last point there. And you need runtime logic that adapts responsively to the real world, right? So it's mentioned with the varying parameters that can change in the real world. You need an authoring tool that helps you define rules to place your dynamic objects. Right, so in the built-in simulation views for Mars, what you see is what you get. Here, visualize your content as your audience will experience it in context. Instead of coding, drag your contents directly into the viewer, and Unity Mars creates the appropriate proxies and conditions. So you're able to build your app with proxies that represents the real world objects with frameworks in place. With a framework in place, you set conditions and actions for your proxies to tell your app how to respond to them. So these are some of the synthetic environments that you can leverage to kind of simulate the world you want to build on top of. With visual aids for fuzzy authoring, you define the minimum and maximum measurements for the real world objects rather than coding precise values. To help you get started, we've provided starter templates, which covers popular AR use cases, including training tutorial applications that work with all our indoor and outdoor environment templates. And so this is sort of a guided training tutorial that lets our users see what Mars is capable of doing. And Mars is, of course, built on top of the Unity editor and works in coordination with AR Foundation, It exists as an additional layer that takes advantage of the data from AR Foundation or other custom data providers to allow creators to build for multiple platforms in a more streamlined and intuitive way. Fundamentally, Unity Mars provides the tools to efficiently author, test, and deliver AR apps. And AR Foundation is what makes it possible to have our augmented reality app work across various platforms. AR Foundation and Mars works together to make it easy for you to create and deploy more interactive apps and intelligently interact with the real world environment. So there is also a Mars companion app. That is one of the newest components to Unity Mars, and it's available for iOS and Android devices. With the app, you can capture real world data directly on your device, bring it into Unity Editor, and quickly create and iterate your AR experiences to significantly decrease the iteration time and deliver an AR experience that accurately runs in its target environment. And Unity Mars gives you this power to perform two primary tasks: data capture and in situ authoring. Right. Using the companion app, you can capture the room scans, take pictures, and record video with AR data. Once saved to the cloud, this data syncs directly to the Unity editor, where you can open it with Unity Mars to create a simulated environment that mirrors where your AR experience is intended to run. And now you have more true to reality development environment to author your AR content. Let's see here. So another example to add to the list of AR utilization is having play-based learning in AR. So in this Dr. Seuss educational app, using Mars allows you to easily classify parts of the environment to help our CG content interact with the world with defined rules, such as only spawning grass on the floor and not on the table, and allowing characters to jump on and off table surfaces, as you see here. Right. So Unity Mars allows you to simulate your experiences within the editor, meaning you don't have to build your app to your phone just to test. This cuts down time significantly in testing and allows you as a developer to just focus on building your experience just right. Okay, second. All right. Lastly, we have Unity as a library. What is Unity as a library? If you have an existing app that's not built in Unity, you can still leverage Unity as a library within your application. And Unity offers controls that let you manage the when and how to load, activate, unload the runtime library within the native application. Beyond that, the mobile app build process is mostly the same. Unity allows you to create and export iOS, Xcode, and Android projects, which you can just integrate into your native mobile app after. So here's an example of how you can load a Unity instance from your native Android app and leverage the power of AR functions. As you can see here, we'll switch to the native app. And when you click the product, it'll just load up Unity. And you have the UX onboarding UI guiding you through it. And there you can see your product now realized in real-time 3D using AR foundations. And you can, of course, switch back to native and go back to Unity. Because Unity has already been loaded before, it's a lot faster the next time around. Cool. And you can use this feature to include Unity-powered features such as real-time 3D and 2D rendering, AR experiences, 3D model interaction, or maybe have some 2D mini games in your application. The Unity runtime library exposes controls to manage when and how to load, activate, download these content in your applications. And that's all the tools and features that you need to know about Unity's AR offerings and AR in general. So here's some resources on samples and demos that you can use and deploy to your mobile devices through Unity right now. So everything shown today are included in the repositories listed here. And with that, I thank you again for having me here to talk to you about augmented reality. Thank you. Let me know if you have any questions.
Thank you, Shawn. It's very complete, rich, and very comprehensive presentations, especially about AR, yeah, and
Thank
also
you.
the introduction about the immersive technology. I think I want to chat with you because we still have time before the first short break. I think we still have around 10 minutes. I see a lot of questions actually. I already have some on my list and also in the question and answer sections. I think I want to recall my memories when I first engaged or exposed with immersive technology. Back then was VR. I'm very impressed, and then I explored AR. I mean, the topic today is about introduction to immersive technology. I think I want to ask your personal experience, Shawn. How was back then when you first exposed or introduced to the world of immersive technology? And maybe you can share some of your first time experience, and then maybe from the audience, I think there are a lot of first timer and beginner that they see your presentation and see the visual use case is very, I think, mind blowing, and they want to start their journey on, let's say, AR or immersive technology in general. Can you share your experience, Shawn, and maybe some recommendation for the first timer?
You mean, just to clarify, do you mean my first time experiencing an AR experience or first time trying to develop an AR experience?
I mean, first time you exposed. I mean, you first know about that.
It's hard to pinpoint exactly what was the first experience, but I guess the most memorable would be the Pokemon Go.
Okay.
Because everyone was was going into the city, and it was just crazy. Every floor of the mall was just people on the escalators just trying to catch Pokemons. So it's one of the indicators that tell you this is a big thing. This is the future. However bleak it looked.
Yeah. For me myself, it feels like love at the first sight when I know about this technology. I'm coming from not a technical background, Shawn. So when I see this, I see the future. I mean, this will be the future we will facing. I mean that kind of impression that I have. And maybe some of the question I want to also ask you in this, maybe later we will have a more comprehensive Q&A session, but here we still have time. I want to ask also, let's say there is a guy or a girl want to start developing AR application or AR project. How they can first start the journey of developing an AR project?
All right, it's okay. No matter whether you have experience in coding or not, the AR foundations is set up in a way that you can instantly just spawn an object in the real world, but just dragging and dropping to a few parameters. Yeah, so AR foundations is the way to go, especially if you also want to build to multiple different devices and leverage the tech on those SDKs.
Yeah. Okay. So I think it's very, I want to ask more, but I need to hold myself back because we can later have more comprehensive Q&A later in the session after the second speaker, Mr. Teck. So I think now it's time, I think, for a very short break before we jump into the next speaker, Mr. Tan, for diving more into virtual reality, specifically more into virtual reality. So thank you so much, Shawn. We'll see you later in the Q&A sessions. So I think I will give back to MC first for the short break. Thank you.
Okay, thank you very much.
So to everyone, there will be a 5-minute break. So maybe you can go ahead and have some coffee, some water, and then we'll see you again in a few minutes. Welcome back to the seminar. Hope you have had a great break. I'll be passing the floor to Antovany again, so he can have to give everyone an introduction to the second speaker.
So we will welcome the second speaker of today's webinar, Mr. Teck Lee Tan. So Mr. Teck Lee Tan is a senior solution engineer from Unity Technology based in Singapore. So, hi, Mr. Teck, how are you?
Hey, how's it going? I'm doing good today.
Oh, very good. So, thank you so much for attending this. So, meeting the expert from Unity, especially VR, because my company, Shinta VR, is also working on VR. So, I think it's like meeting a celebrity, Mr. Teck. It's like meeting a celebrity that can give us more explanation, especially from the perspective of Unity itself. So I think VR especially will be something bigger in the near future, because we know all that Facebook changing the name to Meta, and Metaverse is very closely related with VR. If it's not just VR, it's a whole complex technology discipline, but VR is playing a quite big role in the Metaverse industry. So I think today we will hear more about, maybe first is the introduction about what is VR and what kind of technology is VR. And we will later discuss more on something deeper, more of, let's say, a study case, or probably the possible future that we will be facing in the near future. So I think this is the time for you, Mr. Teck. Without further ado, the place's time and it's yours.
Sure, thank you.
Yeah.
All right, so today, so Sean just finished his presentation on AR. We're going to look at VR and some of the related technologies around that. Oops. Okay. So very quick introduction. So I'm Teck. So I'm a senior solutions engineer at Unity Singapore. I've been at Unity like 3 years now, but I've been working essentially with the engine throughout most of my career, mostly in game development. So joining Unity was actually my first step outside of game development into more looking at more industrial and things like architectural, stuff outside of games, which has been pretty interesting. I spent most of my time as a technical artist in games. So I've gotten to look at a bunch of different technologies. I've worked with VR and AR in games prior to joining Unity. So it's a pretty vast field, and it's obviously it's a rapidly growing field right now. So today we're going to talk briefly about a few topics. What is VR? Kind of an intro to what it is, where it came from. We're going to talk about how it can be used. All the different use cases from gaming and outside. What kind of benefits you can see from using VR over perhaps other media. We're going to look at a little bit at some workflow and examples. These workflow examples aren't going to they're not going to dive too deep. They're going to get too technical, but it'll give you a taste. And then we'll open up for some questions. So what is virtual reality? So in general, the sort of broad picture is that VR is the use of some sort of computer technology. It's usually a head-mounted display to fully immerse your users in a simulated environment. Now, this is actually something that's starting to get a bit blurry as far as the definition is concerned. Traditionally, we think of VR as something where you put on a headset, you block yourself out from the outside world. You see nothing of the outside world. You see a fully virtual environment, whether that's stylized or photorealistic, and you're fully immersed. You just see that. As Shawn had mentioned, there's also this mixed reality stuff. There's been more and more sort of an increasing an increasing use of mixed reality pass-through technology to allow you to kind of blur the lines between AR and VR. Right. So you've got a headset, you've got cameras that are showing you the outside world, but then you're also showing a virtual environment or virtual objects that are overlaid on top of the video feed that you're seeing. We'll talk a bit more about some of the advantages of this approach a little later on. But so one of the main, I guess, components of VR typically, especially now that it's kind of evolved, is you've got that headset. It's fully immersed. It's usually a fairly wide field of view compared to a monitor, and compared to some of the AR solutions that are currently out there. You'll typically also have some sort of motion track controller. These are tracked in different ways depending on the device, and sort of how far along they are on the technology tree. Sorry, I'm trying to get my notes. So a couple of the major players in the virtual reality space right now, at least in terms of market share and public visibility. You've got the HTC Vive. They're one of the sort of earlier major players. There's the Meta Quest now. Meta Quest 2, now that Oculus has kind of discontinued their wired headsets. And then you got PlayStation VR on the console side of things. So you're sort of looking at a relatively small set of major players. Then there are a bunch of, I want to say, smaller players in a sense, in terms of market share for the consumers. But there are a number of VR headsets that are geared towards enterprise solutions, construction, automotive, and these are going to be typically higher fidelity and a lot more expensive as well. So I talked about your controllers and your tracking and your headsets. Now, typically you're looking at a number of different solutions to track both your controllers, and these might be handheld controllers, or they might be your hands, as well as the headset. Now, initially we sort of started off with inertial, like IMU sensors, and all these did was track your orientation. Right? They used an accelerometer to track whether you're facing a certain way or your head is tilted. And this was kind of interesting because when it started, we didn't have positional tracking, and there were all kinds of tricks that, especially like the Rift DK1, the Vehicular one, and like the Oculus Go, that would sort of trick you into thinking that your head was moving. So when you tilted your head, the camera itself would physically move in the environment, and so it would simulate that you're not just rotating the camera, but you're actually tilting your head. And so that they made a big difference in terms of the immersiveness, and also helped a little bit with motion sickness, which we'll talk about a little bit later, which is a big thing. So we also have so that was sort of the first gen of sort of tracking. Then we also have outside-in tracking, which is what we call outside-in tracking, which relies on external sensors. So things like, I think the Vive calls them lighthouses. The Oculus Rift had these little sensor towers, and these essentially track usually IR markers on your headset and your controllers, and these will triangulate everything. Just make sure that the software knows where you are in space. So you're not just rotating your head and tilting your head. You can actually move around your area. The outside-in trackings were interesting. They tend to give you a bit more accurate location sort of tracking. They do have they do have some disadvantages in that you're looking at, you need to kind of set up a larger space. Right? You need to have these lighthouses set up. The inside out tracking, which is getting far more popular nowadays, relies on cameras that are usually IR, cameras that are located, they're arrayed around your headset. And these will typically look outwards. There's all kinds of crazy sensor fusion going on, you know, machine learning, sensor fusion, all that, to analyze your environment and kind of figure out where you are without the need for an external sensor. And this will typically track both the headset as well as your controllers. So these are really cool because they allow you to set up, well, they allow for a much quicker setup. I don't need to go set up a, you know, a lighthouse or sensor tower, calibrate that, and just put that on and it'll analyze your environment. In terms of the types of experiences you typically look at, you can sort of break these down into a couple of very broad categories. You've got your seated or stationary experiences. These are typically used for things like driving simulators, flying simulators. They're also used for kind of easing people in to VR because you've got a safe spot. You're kind of sitting down or you're standing up in a spot and you're looking around. These are really useful for, as I mentioned, driving and flying simulators, just because for higher end sort of things, you might have a full seat built up that physically represents what you're actually simulating. So a little, you know, a cockpit of a plane, you know, the racing seat of a race car. These are also good because you don't need a lot of space. You just kind of sit down or stand up. Then you've got your room scale where you might have a few meters of space. These were really only possible once we started getting things like the lighthouses and the inside out tracking, because it allowed you to kind of move around your space. Then there's the multi-user room scale, which is, you know, things like your VR centers, your VR arcades, the installation style things where you might have, you know, 2 to 4 friends, 6 friends in a space. You might have like things like those Vicon motion trackers that are tracking everybody's location and their poses. And so these are pretty interesting because they allow for, you know, you and your friends to get into the same space and kind of be in the same virtual environment. Now, the evolution of VR is really interesting because it's something that has gone on for longer than sometimes you might realize. You know, a lot of people look at it right now and, you know, think, okay, early VR is basically like the Oculus, right? The DK1, you know, and there's like the Vive. It goes way further back than that, with a large gap in between. But let me see. Oops, sorry. So we've got a fairly long history, sort of long evolutionary history. We've gone from, you see in the top over here, this was, I'll talk a bit about this later, but Dactyl VR, this was actually in the 90s, right? It was just early in the 90s. We had a VR experience, and you know, this was a very simple experience. It was a very rudimentary experience, and we've gone all the way to things like, you know, Half-Life Alyx, which is a very immersive game that, you know, you've got presence of your hands, you're touching things, you're grabbing objects, and you've got a very visually compelling experience, which is a far cry from what you're seeing up top. So I've broken this down into sort of like prehistory, history, and now. So the prehistory, what you're seeing over here on the right is Dactyl Nightmare. This came out in This was, I think, the early 90s. This was, so Antovany and Shawn mentioned, or talked a bit earlier about about Shawn's sort of like introduction or the first experience with immersive technologies. This was mine. Like back in the early 90s, you know, going out to the arcade and seeing this thing, right? I was used to your cabinet arcades or just, you know, pressing buttons and fiddling with the joystick. I see this thing and I'm like, what is this, right? It was a game called Dactyl Nightmare. I think there was another one with a similar hardware, but Dactyl Night was the one everyone actually remembers. It was this, by today's standards, this horribly, you know, low frame rate, ugly, you know, thing with barely any gameplay. You're just kind of running around. There was no, you didn't have a thumbstick. You just had like a one button on your thumb, which moved you forward. And then you had this trigger that would shoot these horrible things at this flying pterodactyl thing. And, you know, again, by today's standard, it looks horrible. It was horribly low frame rate. But at the time, it was amazing, right? You've got this headset, you're fully immersed in this incredibly low poly world. But you look around, you know, I'm looking around, it's tracking my head. I'm moving around and I've got this thing around me to make sure I don't fall down. But you're walking around, you're in this world compared to this flat screen that you normally see in front of you, compared to this joystick. You've got this gun that you're holding and it's actually floating around in front of you and you're kind of aiming and shooting. And it was incredibly cool. Now, of course, back then, it was expensive, right? Both for consumer. I don't remember how much it cost per try, but my parents weren't really happy whenever I went to try it because it was pretty expensive compared to any other arcade game. Development was obviously really expensive because it wasn't something that was available to just everybody, right? You've got this specific hardware that's you know, I don't know how much it cost, but it was probably incredibly expensive. And there was no software, there's no research that's already been done to kind of help you along. So it just had, there was this game and there's one other game by the same company. It was inaccessible, again, hardware, software, and everything was really underpowered. Like I said, frame rate was really, really low. Like you could see the frames kind of pop in. One other thing, so this is a little bit different, but again, this is back in the day. This was, I think, late 80s. There was also, you know, 3D glasses. This was sort of like the precursor, which would use shutter glasses to kind of give you a kind of a depth view of your TV. And this is one of those things where the old 3D movies where stuff would come out at you. So this was, again, very underpowered, but still pretty cool for the time. So then we've got the history, relatively recent history. There was a long gap between Dactyl Nightmare and, you know, Oculus kind of coming into things and Palmer Luckey and, you know, all that stuff. So I want to say prior to a couple of years ago, VR was a lot more accessible than it was in the early 90s. It was still accessible. It was still expensive, both for consumers and developers, for a couple of reasons. The hardware itself, like a VR headset, was starting to get more affordable, especially with Oculus, the DK1. I think I paid about 400 USD for the developer kit. So it was relatively affordable, but you're still tethered to a computer. You still needed good hardware to run your VR experiences, just because of the specific requirements of VR. You need a high frame rate, otherwise you start getting a little nauseous. You're running two separate displays, right? So you're not rendering like you know, a single, like, let's say back in the day, like 1280 by 720 or like, you know, 1080p. you're kind of running that, but twice. So you still needed a lot of hardware to get into both development and consumption. You're not going to get a cheap PC and a headset and start, playing Doom in VR or something. You still need a powerful PC. So it was relatively inaccessible, but it was still consumer accessible. You could still get a good gaming PC and a good graphics card and headset and start playing or developing. The technology and the techniques are still nascent. There's a lot of research that started happening on how to move in VR, how to alleviate motion sickness, how to track your controllers. In the beginning with DK1, there was no motion controllers. It was either your keyboard or like an Xbox controller. Razer came up with something. I bought one of these. It was pretty cool. This thing on the bottom here, which was sort of, I guess you could say it's a precursor to the motion controllers that we see now. These use magnetic. This thing was actually like it generated magnetic field, and the controllers the controllers would be tracked by a magnetic field. So that was really cool, right? It offered up something really interesting. It wasn't great in terms of accuracy, but it sort of offered up a glimpse into the future that we see now. Now we've got something where we've got these really light, relatively light headsets, right? The Meta Quest 2 is pretty comfortable. You've got very light controllers that have like 2 batteries in them. Oh no, sorry, it's like 1 AA battery, right? So it's actually really light. There's no need for sensor towers, set up all over the place. This thing is tracking you internally. There's all kinds of sensor fusion magic for them to figure out where your controllers are, even if they're out of sight. To figure out where you are based on what it's seeing from its like 5 cameras. It's also a lot more affordable to develop and consume now, right? Like developing for VR, especially if you're looking at sort of mobile type VR, like the Quest. Developing is relatively cheap in the sense that you're not looking at trying to build like these big AAA experiences. You're building stuff that can actually essentially run on an Android phone, because that's what the Quest is. And consumption is again very, very much more affordable now, because with this you've got a $300 to $400 USD headset that stands alone. It can run games on its own. You don't need to connect to a PC. You don't need a powerful PC to run anything. So it's a lot more affordable. It's a lot more accessible. The other big thing is that there's been a ton of research now, just over the last few years, into user comfort development techniques, interaction techniques, right? And there's a ton of drop-in solutions that you get like the Oculus SDK, and you've got Locomotion, you've got interactions. Unity has an Interaction Toolkit where again you drop in and you've got cross-device systems for all kinds of different locomotion styles. Now, another big one is you can see on the chart, the usage has grown significantly, right? It's almost on I don't know if you can see the end of this. It's growing not linearly, but like it's starting to get sort of exponential, right? So you're looking at a much larger user base as time goes on. So we can we talked a bit about the history, how VR has kind of evolved over time. We'll now look a bit at how we can utilize it. Now, sort of the more obvious example is gaming, right? Games have always sort of, I want to say the games industry has always sort of in some ways driven a lot of technology, partly because of its consumer-based sort of focus, right? Everything has to run fast, it has to be affordable, and so a lot of things tend to get driven by gaming. And so it's also very visible in the media. so you have a bunch of different kinds of games. You've got VR ports of existing games. This happened a lot more in the early days, where you'd get a first-person shooter and somebody would do a sort of a quick and dirty port where you're kind of looking around in a headset. More often now, you're getting games that are purpose-built for VR. You know, things that really take advantage of your motion controllers, of the body awareness, tracking your head movements and your body positions. So you've got a bunch of really interesting things that are happening, right? Really interesting interactions, like these escape room type games where you're physically reaching for things, turning things, you know, touching things. You've got things that sort of allow you to experience things like, okay, like a military shooter where you're actually sort of pantomiming, you know, holding a weapon, or holding, you know, let's say these medieval games where you're holding a sword. So these are really interesting because they allow you to fully get immersed, not just visually, but, you know, your body awareness of what's going on. Now, there's some really interesting UI and UX things that kind of happen, and this you saw this a lot with again, the early days when there were a lot of VR ports of existing games. A lot of the UI things that you take for granted when you're looking at flat screens, whether it's for games or for applications, a lot of those kind of go out the window. When you're looking at things like sort of tried and true UI methods, health bar, you know, on top. I don't know, let's say ammo counter, bottom corner, you know, I don't know, maybe a mini map, top corner of the screen, where things are sort of like moved out of your visual range, so you can see them in your peripheral vision. All those kind of go out the window when you're looking at VR, because you can't put things out of the periphery, because typically a person is going to at least tilt their head a little bit to look at something. If you put it at the periphery, that periphery starts moving further and further away as you look at it. So a lot of really interesting UI studies have started being done after that initial phase of porting VR things to porting flat screen games to VR. Now, actually, let me go back a second. There was a question earlier on the Q&A asking why everyone's first thought or first like association for VR is games and entertainment. And I think a lot of that kind of comes down to just the visibility, right? Like you immediately think of games just because that's usually what you see in the media. You know, you think of like, you know, these first-person shooters, you think of these escape room games. Those are the mass market stuff. Right? These are things that are going to be visible. That said, it was a good question because yes, there are a lot of applications outside of games. So we have things like data visualization, right, which is actually quite interesting. I would say it started off kind of gimmicky because you're looking at, you know, you're like, okay, hey, here's a 3D graph, and you can walk around it, and you know that was basically it. So, but there's a lot of really interesting uses for these kinds of visualizations, right? Molecular visualization. You know, we'll walk around, you know, a chemical like a chemical structure, and you know, structure of atoms, and really kind of literally like put your head in, kind of dive in and look at these things up close and see the spatial relationships. I think that one was actually the really big one, was when I tried out some of these data viz. The spatial relationships became really clear because you're kind of walking around these things. The collaborative viewing is pretty interesting just because you've got a bunch of people, whether it's in the same room or virtually, looking at these structures, these data structures. There's also, you know, sort of a with I guess the relatively recent trend in the last few years of moving towards, you know, what they call beautiful data. Having data visualized in 3D and VR makes for opens up a lot of possibilities for that beautiful data. Now this one kind of goes towards that question, where there are a bunch of use cases in or AEC, architecture, engineering, construction. You got manufacturing, automotive, medicine, military, and these run the gamut, all over the place, right? Like, you've got vehicular simulations, whether that's a plane. So you see over here in the first screenshot, you've got a pilot, running through like a pre-flight checklist, right? Because you've got all the switches physically there. You gain all this muscle memory, you gain all this spatial awareness of what's going on. You can run through a pre-flight checklist on a computer, just literally run through that checklist and say, okay, yes, I gotta flip this switch. Okay, yes, I gotta start the engine. Yes, I gotta do this and that. But actually having to sit there and reach out and flip a switch, press a button, introduces a huge amount of, your muscle memory, and you obviously remember better by doing than by seeing or, reading. There's things like virtual surgeries, which is also another big one, whereby you're looking at being able to put on a headset and get, some custom hardware that allows you to perform, let's say, a virtual surgery, an incision, some sort of, heart bypass. And the huge thing about this is that obviously being virtual, this is a vastly cheaper, and a lot more, it's a lot lighter on personnel resources than actually running a, whether it's a physically simulated operation or having interns, kind of do their training on actual people, right? There's only so many people you can run through in a day, or a week. Whereas with a virtual surgery, you can just kind of run that, get it down pat, repeat it. So it's cost saving. There's the immersiveness and just the learning potential. There's military police training. You got equipment training. Again, being there physically and actually seeing and flipping switches physically is a huge game changer. One kind of interesting one is over here on the bottom left, where there were construction companies that were using VR to kind of do virtual onboarding, both in terms of safety, like, hey, get your helmet on and all this, but also in terms of just kind of getting your first virtual look at what it might be like to be on a crane, like 100 meters up in the air with simulated drift, right, as the structure is swaying, and that kind of gives you a really, actually, a surprisingly good feel for like what it might be to look down when you're 100 feet up in the air on a swaying crane. So there's a lot of really interesting use cases there, again, outside of games. Some other interesting use cases, you've got physiotherapy, psychotherapy, diversity training. This one in the middle is pretty cool. It was this was several years ago, but it was a vaccination app for kids, where kids would come in. I think it was in Spain, if I remember correctly, but kids would come in, put on a headset, and do their vaccinations with this little character who essentially represented the nurse, walking them through this, their vaccination, their jabs, and from the case studies that they've shown, it made a huge difference in terms of just the kids' comfort level, right? They're like, okay, hey, I'm a hero in this kingdom, and I'm getting my jab now. So there's some really interesting use cases, and there's the physio and psychotherapy, where you're looking at, if you're trying to retrain your legs, right? You've lost the use of your legs, you're retraining them. There's only so much you can stand on a treadmill, or like stand and hold yourself up and just kind of walk day in and day out, when you're just looking at you're looking at like the therapy center, right? There's only so much you can do without, kind of losing it, right? So what some centers are doing is basically kind of giving you a headset. And so as you're physically walking on your treadmill, you're actually virtually walking through like this this nice meadow or this forest, this beautiful fantasy place, which gives a lot more, I would say, a lot more motivation and also kind of just a lot more visual interest to the people who are actually going through this therapy. Diversity training is another interesting one. I had a friend who ran this company that was doing VR diversity training, where one of the interesting things is that you put on a headset and you essentially embody somebody that you're not. Going through, you know, situations, let's say in the workplace that you ordinarily wouldn't, as let's say, you know, let's say for myself, like a Chinese male in Singapore, right, or in Australia, like a white male person who might not experience, let's say, you know, as a female employee, things that are said, situations that are put in. So kind of putting yourself physically and virtually in that situation makes for actually a very compelling experience. Then, of course, there's, you know, everyone's new favorite word, the metaverse. And, you know, obviously, Meta, Facebook, is driving, you know, well, they've got a lot of money invested in kind of building this out, but they're not the only player. You know, there's a lot of people, a lot of companies that are doing this kind of thing, right? Your virtual meeting rooms, your shared environments, your shared experiences. There's something to be said for having a virtual, you know, meeting room or a virtual sort of space where you're gesturing, right? You're gesturing, you're virtually patting each other on the back, virtually high-fiving, and kind of walking around a space and physically pointing at things, right? That's huge. And so that's starting to become, you know, more and more prevalent, right? There's like Facebook Horizons, yeah, there's all kinds of virtual meeting rooms and virtual spaces that are coming up. And of course, these run the gamut from like being slightly more realistic to very stylized, that, you know, the Facebook sort of approach to going super stylized and super cutesy. So somebody's all right. So what benefits can VR offer? Now, I put this picture here as a joke, but it's something I think we've all sort of seen. It's something we've all experienced firsthand. So training and education, right? Sorry, I think somebody's not on mute. Okay. So when you're looking at training and education, when you're delivering some training, having a flat screen and sort of like a quiz, right, or a lecture that's being delivered, you know, sort of ironically, such as this, there's a certain amount there's only a certain amount of concentration that they can, you know, give over a span of time, over the span of the day, when you're sort of just consuming. Having a VR training or VR education immediately kind of gets you more engaged, right? Immediately keeps you more awake and focused. I've definitely fallen asleep in lectures when I was in college. I have never fallen asleep with a VR headset on my face. You know, take from that what you will. But typically, you know, as I mentioned with the you know, vehicle simulations and sort of equipment training, being able to physically, you know, to physically look around and see your environment, to physically see the equipment that you're interacting with, and then physically reach out and touch it, flip switches, press things, makes a huge difference in how you're actually learning, right? You're actually doing, you're not just sort of consuming and kind of clicking buttons. The other big thing is that it's also more cost effective than like physical mock-ups. I've spoken to like defense contractors that have been running, you know, virtual trainings, and, you know, to fly, like, let's say an engine, right, or say a piece of equipment to test engines on like an F-16, let's say. To fly something out to a location is hugely expensive. There's insurance, there's the transport costs, and there's all this. And there's only so many pieces of those equipment that you can actually fly out. Whereas with virtual, you've got something that you can just have everybody. You can have like 20 people running those trainings at the same time, getting the same or similar muscle memory and spatial awareness. And the other thing is safety. Working on an engine virtually versus physically, at least for the initial phases. There's no getting around the fact that you will need physical, actual, equipment training. But having this virtual training allows you to kind of get over to that initial hurdle, the first 100 hours, or let's say. Now there's also interactive and actually also non-interactive entertainment. Now some of the benefits of this include like your immersiveness, right? The immersiveness actually kind of runs through all of these as a common thread. The immersiveness, right? Just whether you're in in an installation VR thing with your friends and seeing things. I think the first time I went with one of my friends to one of these VR places, we were doing a shooting game or something. So they did all the calibration for getting your height and your pose. But one thing that was cool was that my friend was a good deal taller than me. He was at least a head taller than me. He was a head and a half taller than me. And just sort of that realization that when he said, hey dude, high five. And I turn around, I look over, and I'm about to high five, and I realize I'm high fiving him like up there. Like that in itself makes a huge amount of difference in your immersiveness. The other thing is the natural control, right? If you're doing interactive entertainment, whether it's holding, gripping a gun, gripping a sword, flipping switches, grabbing a wheel and turning it, right? Physically kind of turning it is really there's something to be said about doing that versus I don't know, turning your thumb on a controller. And of course there's the storytelling aspect, right? Just kind of being there, seeing things. And again, this can be for both interactive and non-interactive. There's a bunch of sort of 360 style movies that you can put a headset on and just kind of look around. So those are really interesting. Then there's the visualization of things, right? Having an object in front of you, whether it's a car, whether it's a piece of equipment, whether it's an environment that you're looking at, right? Again, the immersiveness, right? But really having that spatial context, right? That sense of space is something that can't really be done in on a monitor. My boss told me the story about this time he was trying to mock up like an architectural like an interior design, and his designer kind of looked at it and said, dude, it's too small, right? It's too short. And looking at it on flat screen, it's like, that looks fine. He put on a headset and was like, oh yeah, it's actually really, really small, right? It's like, the ceiling height was actually a lot shorter than he thought it was, just from seeing it on a flat screen. That depth perception is actually a huge factor. Yeah, and then just kind of whether it's looking at a virtual environment on a flat screen or just looking at blueprints, right? You can get a certain sense from a blueprint, like a plan view, but there's only so much you can kind of grok out of that. So one thing that Sean's kind of touched on was the whole mixed reality thing, right? There's a number of headsets now that are introducing this concept of basically mixed reality or pass-through, where the headsets themselves actually have outward-facing cameras that you can view, that you can kind of that you can see their things, and there they do again all kinds of sensor fusion to stitch all of these wide-angle camera views into one sort of relatively seamless view that you can kind of look around. Now, the major advantage of this versus, let's say, like a HoloLens or like a Magic Leap is that due to the nature of the HoloLens, you're basically sort of like additively layering something on top of what you're actually seeing. Now, what this results in is something like what you see on the left, which is, you know, if anyone sort of tried a HoloLens on, it's cool, but you're never going to get something that's fully opaque, right? Because you're literally just overlaying something on a transparent screen. And so what the mixed reality stuff like the Vario and to a certain degree the Quest 2 is that it allows you to overlay a fully opaque image on top, or sort of fully opaque environment or object on top of a video feed, which means you're actually seeing this thing in the environment blocking things. And so what Vario did with Volvo was that they actually had somebody driving. It was very closed conditions, you know, roadblocks, no other cars on the road, but they actually had somebody driving with a headset on that was feeding full, you know, I think it was 4K, you know, video, color video through to the display, and then overlaying, you know, safety information. You know, it's like, here's a virtual moose crossing, so you know you need to stop, and it would actually watch this moose actually, you know, cross over and have all of the you know the information displays on top of that. Right. Similarly, we've got something that our labs are doing, which is this mixed reality pass-through. This will be available at some point this year as a demo. But essentially, this is using the So yeah, so examples of this stuff is like currently the Quest 2 and the Vario. I think there are a couple of others that are kind of experimenting with this as well. So we're going to look at a couple of things slightly more technical now that will kind of give you a head start into what you might be looking for to start development. So one of the things that we've been working on internally is this interaction toolkit, this XR interaction toolkit. This actually does also handle AR stuff. It has a couple of sort of AR drop-in components. But currently for VR, we've got a lot of cool things that are just basically literally almost literally drop-in prefabs or components that you can just add to your scene. So I want to put on my old man hat and you know, say that when VR was sort of not first starting out back in like the Dactyl Nightmare days, but like with the Oculus, the DK1, what you were doing a lot of times when you're developing for VR was figuring things out, right? Figuring out how you're going to get interactions, figuring out how you're going to do head motion, figuring out how you're not going to get your users sick, like motion sick. You know, coding your own stuff like, you know, grab interactors, touch interactors, you know, pointer interactors, and you're coding all that up, you know, writing that, building your own stuff, just rolling all that. So nowadays we've got all kinds of frameworks that let you kind of just drop this stuff in, right? And all the research, well, not all, but you know, a lot of this research has been done already, right? How are we gonna, you know, translate your motion controller to grabbing and touching and pointing? You know, how are we gonna handle locomotion, right? For different types of people who are okay, who don't get motion sick, people who get motion sick super easily. All right, so all that stuff is done. Your components are basically drop in. So the XR Interaction Toolkit, it's available as a package. allows you, or it provides a bunch of high-level component-based systems for you to create these experiences. All right, so it provides out of the box, a bunch of different locomotion interaction systems. You've got your teleport, you've got your dash, you've got your smooth locomotion where you're just using a thumbstick to smoothly move around. You've got your interaction systems like grabbing stuff, touching stuff, working with UI. So, this is just one example where just from this menu, just, add a grab interactable, and this will basically give you your first building block, which gives you how are you going to grab it. It handles all of the hard stuff, right? Sets everything up so you can just grab something, and then you can kind of tweak how you want that object to behave when it's grabbed. You've got all these events like when your controller hovers over this object or this collider, what can it do? Does it glow? Does it start pulsating? Does it run an animation? Similarly, things like your locomotion systems, right? Again, drop in. You add one of these things and you've now got a teleport provider. You can drop in. There's also like teleport anchors and teleport areas where you can just drop those in. And this sort of handles everything, right? So you just point, teleport somewhere. And it's so easy compared to when we're starting out where everyone's kind of building their own systems and kind of figuring things out. So a couple of things, slightly more technical again. When you're looking at developing VR stuff, one of the really big things is performance, right? Again, I sort of mentioned early on how early VR was really expensive to get into. It was not accessible to get into because you needed really powerful PCs and to actually even just consume. And the main reason for that is frame rate performance. There's varying numbers now. Like I think the old sort of like standard was you need to have a minimum of 90 FPS to ensure that people don't get motion sickness. This is sort of moved around a bit. The Quest was 72. I think the Quest 2 is like 80 or something like that. But they do rely on other tricks to smooth out that frame rate. And so you generally just want as high a frame rate as possible, just so that you don't get this sickness. A good example, I think, was I was trying out Half-Life Alyx. Any change in frame rate, any significant change in frame rate or drop in frame rate will immediately make you sick. I think I had one moment where I was in a fairly intense situation. I was moving around a lot, and I think my PC crashed. And so I was left, as I was moving, I was left with a completely static image in front of me, and I was still moving, and I immediately had to take the headset off and sit down for a bit, because your inner ear does the VR headsets do a surprisingly good job of tricking your inner ear into feeling that motion. So you want to keep that frame rate up. We've got a few tools in the editor that are available that'll help you do that. Your profiler, your frame debugger, which lets you kind of step through your frames to figure out which part of your frames are, which part of the draw sequence is causing, a lot of your frame rate issues. Latency is something that'll come from different things. If you're on a wired versus wireless headset, the network might contribute to that. But that really comes down to, that really refers to things like how much delay there is between moving your hand and the virtual representation moving, as well as, more importantly, the delay between moving your head and your virtual camera actually moving. So that plays a huge part in sort of alleviating motion sickness. The less latency, the better. Locomotion is another big one, right? There's a few sort of methods of locomotion that that are kind of the standard nowadays. But a lot of things that you want to look at when you're sort of looking at first-time users or users that are not too experienced with VR. And these are sort of based on sort of research that has been done since the start of like this VR thing. So one is constant velocity, right? You basically tend to want to not do a lot of like acceleration and deceleration when you're moving. So again, a lot of the stuff that you do in like flat games where, you know, you want to have this nice smooth acceleration when you push your thumbstick, and then when you let go, you kind of slowly stop. That tends to actually cause a lot more motion sickness. So you want to just kind of start and then stop. You tend to want to have a static point of reference. So driving simulators tend to be good for this, just because you have a literal frame of reference around you. This helps to kind of trick your brain into, or rather, it helps to ground things, right? It helps to trick your brain, thinking like, okay, I am actually sitting here, and I've got this thing, and I can see how things are moving because I've got the static point of reference. Something that still tends to be done nowadays is this dynamic FOV. This is sort of a virtual static point of reference, because you've got you kind of tunnel vision, right? And you've got this literally static point of view around you, and so that it kind of looks like you're looking through a window. So that helps a lot with motion sickness. And then there's like the teleportation and snap turning. So instead of smooth turning, instead of like smooth motion, a lot of games nowadays are doing a lot of the smooth motion just because gamers are getting more used to sort of like doing that. But there's always going to be teleportation and snap turning as sort of like usually the defaults. So the static point of reference. So when you don't have a static point of reference, the first thing I did when I got my first VR headset was I did a roller coaster, and I almost immediately got sick because it didn't really give you there was a static point of reference. If you look down, you could see the cart, but if you're looking straight ahead, you got nothing. Right? So all you're seeing is this track and the environment as you're moving. Immediately get sick. So having that static point of reference, go easy on your user. If you're doing a first time thing, don't immediately throw them into this high speed, twisty sort of environment. You know, so if you can see over here, there's a static point of reference. You've got a cockpit. It's not really obvious here, you know, on a flat screen, but in VR, having that static point of reference is a huge help in terms of grounding you. Different controls, right? Like when you're looking at controls, you can do a bunch of things. You can utilize a bunch of things like motion tracking, you know, position orientation, velocity. One thing that you can do that tends to be overlooked now, but is still actually really useful, is using your gaze, right? Where are you looking? This can be subtle, like not starting, let's say, a cutscene or something, unless the user is actually looking in that direction, not starting an animation or, you know, something. So that's actually still really useful. But with motion tracking, there's a lot of interesting things you can do, like tracking velocity, right? Whether it's linear or angular. This game I've been playing, that's actually one thing I didn't actually mention in the benefits is actually fitness. I've been playing this. One of the games I've been playing is this boxing game that tracks your velocity, your controller velocity, as literally the power of your punches. And so I'm usually just completely wiped out after about half an hour playing this. But that's something that you can do, is that because you can track position and velocity, you can make use of that. Also things like the spin rate and whatnot. So there's a lot of really interesting things you can do, and also hand tracking, which has been something that the Quest 2 has introduced quite actually impressively, right? So instead of having a controller. Now, one thing nice about hand tracking is that it does tend to be a more sort of an easier introduction to a first-time user, like somebody who's not played games, somebody who's not played games at all. To us, to gamers, like, you know, you get a motion controller, it's like this is perfect. There's buttons, there's thumbsticks, it's great. To somebody who doesn't know it, like I've, you know, first time I handed one to my wife, Just all thumbs, right? It's like, I don't know what I'm doing. So having something where you've got hand tracking and you're just literally reaching out and just flipping switches or touching something or kind of doing the whole Minority Report thing, right? That becomes a really good potential alternative for experiences that are perhaps for people that are not as used to gaming. So extending the experience is also another interesting one, right? You've got bespoke physical controllers. You've got haptic controllers that are coming out. You've got this really goofy one over here. I think it's still in development. It's a smell-o-vision. I think they call it smell-o-vision. It's literally just kind of like simulating odors, right? Smells, which can actually be kind of interesting. You've got things like this where in the environment you might have like fans that will kind of give you the sensation of wind, right? Or acceleration. And this one is actually a really interesting study that there's a lot of really interesting science going on there. It's beyond me, but where it tracks your eyes and the eye saccades, like how your eyes are kind of looking around, and it sort of virtually shifts the camera subtly to make you turn, right? Physically while thinking you're going straight. And so it virtually sort of extends the room. I don't know how it works specifically, but I tried it and it's actually really surprisingly effective. So let me see. Yeah. So again, performance. So this thing on performance, biggest thing here is you design for your experience, or you optimize and design based on your experience, right? Whether you're looking at a small enclosed environment like an escape room, or big virtual environment, a big open environment like PUBG or Population 1, right? And so you want to figure out what you're doing first, settle on that, and then kind of figure out how you're going to optimize that, because you're going to be able to do different things based on what you're designing around. Smoke and mirrors, that's a big thing in VR, right? Fake what you can, bake what you can, bake your lighting, bake your shadows. The less that the GPU has to do, the better, because then all of that computation power can be used for tracking your position, doing all sorts of gameplay stuff, right? Anti-aliasing is actually a surprisingly big thing with VR, because it does help with shimmering in the distance, which can kind of take you out of the experience. Oh yeah, and the last thing is actually really, don't overcomplicate things. Like whatever you can fake, if you can have a static image in the background that works, especially if you're looking at like distant stuff where you don't really get that parallax. If you can get a static image, use it, right? Do what you can to kind of simplify as much as possible. So this is the last kind of bit. I mentioned earlier frameworks. There are a handful of interesting frameworks out there. There's the one that we offer as a package, XR Interaction Toolkit. There's VRTK, which seems to have slowed down development a bit, but it's still in active development. It's an open source toolkit that kind of similarly has a lot of drop-in components, locomotion, interactions, things like that. And there's the OpenXR and the Oculus SDK, which kind of handle, well, OpenXR is sort of the open thing for like, but typically like Valve, like the Vive and whatnot. And there's the Oculus SDK, which you will actually need if you're kind of looking at doing hand tracking. And so that's the Oculus specific one that you will need to develop for Quest specifically. But otherwise, the XR Interaction Toolkit does give you stuff that'll go cross-platform or cross-device. And with that, that's it. Got any questions or?
Okay, thank you so much, Mr. Teck. It's very enlightening and mind-blowing presentation from you. So I think it's very wonderful. Let's say if I can personally give my testimony on how we apply VR in our, let's say, daily life or business. me myself in my own company right now, which is Shinta VR, we do a lot of things with VR. We use Unity as our game engine to develop more of our projects and also our services and product. I want to highlight some of the explanation before that mentioned by Mr. Teck, that now VR especially is getting more and more easier to access. And we see that the pricing of, let's say, head-mounted VR is getting cheaper and cheaper. Like everyone start adopting and buying VR headset and experience what kind of VR technology in different type of cases or experience. And the second one I want to highlight is VR is not just about gaming. I mean, Mr. Teck already explained lots of study case ranging from, let's say, psychology, mental health. We can also do some of the industry training, educations, and all different type of scenario that we can build on top of the VR technology. So I think that kind of possibility, I think I want to highlight that because I see some of the audience see that they still see, let's say, immersive technology is like only like a few people understand, or like it's very complicated, or it's a sophisticated technology that hard to understand or hard to access. But in reality, here we get explanation both from Shawn and Mr. Teck that it's getting easier. Okay, we are entering the Q&A session. So let's say the rule for this Q&A session, I will let everyone to raise hand if, let's say, you guys want to ask live questions, or you can just type in your question in the Q&A section. So later we will try to like discuss about the question that you want to ask. So I welcome Mr. Shawn and Mr. Teck to jump in to the Q&A sessions. Actually, I have tons of a question. I think the audience also have similar, I don't know, something in mind that maybe want to ask of you about your wonderful explanation before. And I also have some of the listed questions that I already take notes before the webinar. So I think I want to ask this first, Mr. Maybe you can both answer from both of your perspective. I mean, during the journey of immersive technology adoptions, especially in Southeast Asia, we are all in Southeast Asia, right? I'm from Indonesia and Malaysia and Singapore. So now we're talking with Brunei. What kind of adoption that you guys have in mind, especially, let's say, to introduce this technology to this region, like Southeast Asia? You can also like give testimony from perspective of your own country, let's say Malaysia or Singapore, or let's say the case of Brunei itself. What kind of recommendations, or let's say something, or what type of mindset we need to adopt to fully utilize this immersive technology? I think I will give first opportunity to Mr. Shawn to answer.
So your question was, just to clarify, how can we drive adoption of AR and VR experiences?
Yeah.
Well, I don't really have the answer for that. I think everyone's trying to figure that out. Sorry, I think there's drilling happening. But yeah, I think everyone's figuring that out. And it's great that people like Meta are stepping up and really leading the way in this space. And I think what we can do is just try to make it an experience that's more ubiquitous across all platforms, and have just keep pushing the experience to provide value to the users, right? Whoever is engaging in AR or VR experiences, we need to focus on the values. Once we are able to create that value for their day-to-day lives, it's when adoption would naturally come in.
Yeah, of course. I mean, lots of cases like you already share, like Mr. Shawn and also Mr. Teck, that a lot of use case that Unity has now. And is there any like specific use case that adopted in, let's say, Southeast region or like Southeast Asia countries that maybe you guys can share to the audience?
Let's see. I think I'm trying to think of. So there's one that comes to mind. It's not Southeast Asia specifically, but it's still within the SAPAC region, I guess. In
Okay.
Australia,
Okay.
I spoke to somebody running a VR company in Australia,
Mm,
and he was telling us about this app that he was developing for VR. So it was VR. It was for the Quest, if I remember correctly. So it's a
mm,
standalone, and it was meant to. It was basically meant as a training, sort of a training application for.
mm,
I think it was basically like EMTs and nurses,
mm,
so medical staff, and it sort of at the start I think it was a fairly focused in the sense that it really covered sort of your basic EMT functions, CPR, dressing wounds, things like that. But what it did was it would basically walk the trainees through these really important steps, right? That and I think I forget what the adoption was like, but it basically became like one of the official training apps for a couple of the hospitals in
mm.
I think it was Western Australia.
Yeah.
Um,
Yeah.
and I think that sort of speaks to some of the I guess the utility of
Mm,
these immersive technologies, right? Like being able
yeah.
to see the patient right in front of
Yeah.
you,
Yeah.
being able to kneel down because the patient's
Mm,
on the floor, right? So you can kneel down,
mm,
perform CPR or like check their wounds, things like
yeah.
that. I think
Mm,
that's that's pretty huge. And
yeah.
again, the whole like going through a checklist is one
Mm,
thing, but actually like physically performing that checklist is another thing entirely.
okay. Yeah. So if I may share my own experience about adopting immersive technology, I mean, lots of industry now. Of course, I think the momentum is coming because of Meta. I think when Meta shout out to the world that okay, Facebook will work on Meta, and then everyone start to develop their own metaverse or what's so called immersive project. Here in Indonesia, also the same. I mean, government sector also start to adopt. I don't know. Is it still a buzzword or is it starting to get real? I mean, all the people here discussing about that. I mean, all the in the comments in the Q&A section also. Some of the questions is about metaverse. We will later move to that. But before that, I want to try to give. I want to ask, like, let's say, I think from the audience that we see today, there's a lot of first timer. There's a lot of the one that want to start the journey of VR and AR. I mean, if you can give tips or give some, I don't know, hacks for the one that want to start the journey. Let's say AR from Shawn and VR from Tech. What kind of recommendation that you want to give? Maybe Tech first. I will give this opportunity to you first.
Sure. So you mean like in terms of what resources to look for? Is that what you mean?
Yeah, it can be anything. It can be the resources or let's say what kind of recommendation, let's say from your personal experience. Let's say let's say what people coming from tech background or non-tech background, they want to start their VR experience journey. Yeah.
Right.
Yeah.
So I guess I would say like if you're looking at like actually honestly like whether you're looking at consuming or developing right now, I
Mm,
think
yeah.
just from my own personal experience and just the reality of the numbers,
Mm,
I think the Quest 2 is actually just one of the best options for you out there.
mm,
It's I think it's the most affordable headset out there right now. And
mm,
it's
yeah.
also shockingly capable for that price. I mean,
Yeah.
you got your
Yeah.
inside out tracking, you get pass through,
Yeah.
you've got full motion control,
Yeah.
for like 300 USD, right? Which is pretty shocking considering the first Oculus, the first DK one was like 400 or 500 USD,
Mm,
and you needed to hook that up to a PC, right? And so I'd say like whether it's consuming, there's a ton of content out there for the Quest. Um, or developing. You've got, there's like drop-in solutions already, whether it's the RTK, the Interaction Toolkit, or
mm,
even
yeah.
just the basic like Oculus SDK. I think
Yeah.
jumping into that is probably good. I think one I think one important thing is to actually really, I think finding that I think as Sean mentioned, right, value is something, right?
Yeah.
So finding something that you're kind of keen to kind of solve, right? You know, whether it's a problem to solve or just something that it doesn't have to be like some life-changing, world-changing like thing you want to solve. It could be something interesting that you want to solve, or something that you've seen that you might want to try to replicate. So having that goal, and then just really the I guess the boring part is actually really interesting, is looking into all the research that's been done, because that gives you a lot of insight into you know, even if it's just sort of a like a high level overview of things like motion sickness and user comfort. Those are actually a really important part of it, because as somebody mentioned in the Q&A, like, you know, some people will put on their headset and like within like a couple of minutes they'll be motion sick. So kind of having some understanding around that is really important.
Yeah. How about you, Mr. Shawn?
So getting into AR, there's a lot of ways you can get into it. I think someone in the chat mentioned that Unity does have a learn portal. It's called learn.unity3d.com. And that is really one of the best places to start off with, whether you're learning Unity, just Unity, or Unity for AR or VR. We actually have, it's quite up to date. I have to give a shout out to the team handling the Learn portal. We even have a course partnered with Oculus, just specifically on developing for Oculus. From the moment of from the design stage, the idea inception stage, through to deployment stage. That's about 20 hours of Oculus development content on the Learn portal. But if you're someone who's not technical and who doesn't code, there is still Unity visual scripting that's available, and it's just an interface for you to drag and drop logic nodes to create interactions that you want. If you want something far more simpler, where you can just drop a 3D object in Meta, or Instagram has a tool set called Spark AR. That's easy enough to just keep your feet and just dip your toes in it in just like a few minutes. That's something you can try out.
Okay. Yeah, pretty interesting. Yeah. I mean, one question later after the answer you both gave is, what kind of specifications, what kind of, let's say, basic technical knowledge that probably, let's say I'm a student, I want to learn some of like programming language, and I want to focus on, let's say, AR and VR. What kind of recommendation from the perspective of like, specifications or the programming language that you guys both recommend to, let's say, complement or support the journey of AR and VR? Mr. Shawn, you can answer first.
You mean like getting into coding as a beginner? Right.
Yeah. Okay.
I would recommend it the way I got into gaming development and learning programming as a whole, is make a game. Because I don't think there's any other way of learning coding that's more fun than actually making your own game. Right? It's a very rewarding experience. And I highly encourage it.
Yeah. How about you, Mr. Teck?
I would say the same, because that's pretty much how I got in as well. I mean, okay, my initial sort of like introduction to coding, where I actually got really passionate, was it started off with like modding, right? But really starting to learn things properly and kind of expanding that knowledge came from when I actually wanted to be like, I want to make this silly game. I wanted to make like this Excitebike clone, you know, and you know, you start small. One thing is don't aim for like, you know, don't build like an MMO right on your own. Start small, right? Find something that you want to do. It might be a game, it might be something that is less gamey, but you know, something that's interactive, right? A lot of the VR developers that I've spoken to or seen like on Reddit, you know, some of them start off like by building games. Some of them start off be like, you know, I just want to do something with VR, right? I want to be able to visualize something in VR. I want to be able to do hand tracking, like just knock something, just literally like use my hands, just knock something off the table, right? So kind of starting with that, like finding that initial goal and be like, okay, I'm gonna do this, and then how can I, like, what do I need to learn to make this, small, whether it's a small game or a small interactive experience.
Yeah. Thank you so much for that. And yeah, we're moving now the discussion about the future. I mean, I see lots of questions here about what is the possible future that the terms metaverse come, and before we know metaverse, we know immersive technology. What do you guys see actually from the perspective of your professional experience or your in technical journey in this type of technological development in the future? What kind of future probably Unity will aim, or let's say the immersive technology itself, or even the metaverse? What kind of future you guys projecting? I mean, you can start, Mr. Teck.
Well, I mean, I think as a company, we're fully invested in the metaverse. Our CEO he's pretty bullish on the metaverse. I think and it makes sense for us as a company, right? Like just the things that the areas that we're involved in, and I think also I guess what we've seen, whether it's clients, whether it's users, and how things have gone on. If you think about it just as even if you just sort of think of it naively as sort of a larger version of multi-user experiences that we've seen with certain clients, automotive industry clients who are, say there's like, say 10 people scattered across the world, across different disciplines, reviewing, the latest prototype for, a vehicle design, right? All walking around the same thing, but all in different places. One's in the US, one's the UK. They're all just walking around the same environment. They're all seeing each other point, and they're talking, they're waving, gesturing to each other. I think even just looking at that, right, as naively a bigger version of that is already pretty compelling.
Yeah.
And of course, there's all sorts of interesting discussions, that are going to surround things like monetization and ownership, and of course NFTs, and all these really interesting sort of discussions that are going on right now.
I think game life will become like a real life, right? We used to enjoy gaming like so much. We design game, we play game, and now the gaming experience that we used to be in just like a console, now we're moving into like the real world. Okay.
Yeah, I mean it'll basically be like either. Okay, so I guess if you want to sort of look at it like pessimistically, it's either going to be like the Matrix, where everyone's just shacked in and just kind of just eating slop, right, in real life, or it'd be like in like Wall-E, right? Everyone's just kind of like just rows of people just sitting there like
there's a lot of possibilities in the future. I mean, there is an upside and downside of the technological advancement. Okay, Mr. Shawn, what is your I don't know argument on this?
Well, of course, I share the same sentiments. Tech, we echo what our CEOs, talking about the metaverse is. We have a big role to play in the metaverse, especially in Unity. We see ourselves as enablers for content creators to contribute to the metaverse. If you take the analogy of like a gold mine during the gold rush era, we'd be the ones selling the pickaxes for you to dig for that gold, right? So yeah, in that sense, we have a huge role to play to just enable more people to be able to contribute. We believe anyone and everyone should be able to contribute to the metaverse. The world is a better place with more creators in it. That's our mantra. That's how I see it.
Yeah. From your personal point of view, what is the industry that first will be disrupted, or let's say will be like massively impacted by, let's say, the rise of Metaverse?
The industry that would be most disrupted, I don't quite have an answer for that. I think everyone would actually kind of catch on at their own different pace. It would be disruptive in all different industries in their own way.
Yeah, some mention education, some mention real estate here, and some mention about, let's say, military. There's a lot of possibility because the possibility is limitless, right? In this new world of Metaverse. So that's why, from the, let's say, technical point of view, it can be anything, right? So we cannot put like our own personal comments on, let's say, the certain industry will be impacted or another one will be less, because it's still evolving, right?
Especially at this point of time where almost everyone has a different definition of what the Metaverse should be.
Yeah. I think I have also the same concern here when we try to educate the people, especially when I talk. I join a lot of webinar actually, and I'm asked to explain what is Metaverse and what kind of fundamental knowledge you need to know, because sometimes it triggers creativity and it triggers imaginations. People try to simplify everything. Let's say, okay, we can do this, we can do that. But let's say in technical development, there is still some, let's say, handicap or limitation, right? That we still have now. Let's say, I don't know, is it network or is it device or what kind of limitation actually? Let's say from both of your guys' experience, what kind of limitation that still help the development of, let's say, immersive or Metaverse? What kind of limitation that we face now? So everyone know that, okay, there is still a limitation. So we cannot do, or we cannot fulfill this type of imagination. What kind of limitation?
I guess I would say, I think one limitation is still cost. I think one question just came up in the Q&A where, are there going to be even cheaper headsets? And I think there will eventually. I mean, just the economies of scale are going to force it down that direction. There will be cheaper headsets. I guess in a way you could say like the Google Cardboard was a cheaper headset, but you still need a phone, right? So, but I think there will be cheaper devices, right? Cheaper ways to develop, more drop-in stuff where literally just a non-technical developer can come in and say, okay, just drop in, drop. Okay, I've got an experience now. But yeah, I mean, I guess in terms of other limitations, I think one is that just there's still limited computing power, right? There's only so much we can do, whether it's so it's either you go for very realistic, very photorealistic experiences that require an expensive PC and an expensive headset, or we go something that's more accessible, cheaper headset, but is not going to be it's not going to be the Matrix. So there are still limitations there, and then I think some of the stuff is kind of designing around that. So if you look at what Meta is doing now with like Horizons, it's very specifically stylized because it's got to run on lower end devices, and it's got to have you got to have a lot of say like avatars on screen. So they go for something that's more stylized in order for them to be able to kind of build those models in a more efficient, more optimized manner. So there's sort of like there's always going to be interesting things to kind of like work around.
Yeah, of course.
There are ideas pitching that the Metaverse doesn't actually have to be all VR. It can be exist in other spaces or just on your computer. In fact, some people say the Metaverse is already here or always has been here. Okay. And I think
it's the internet.
Yeah, it's the internet. One of our developers at Unity actually wrote an article, I think, saying at the end of it all, the Metaverse is just the internet arranged spatially in 3D. So that's how we think of it. And I think ultimately the challenge is just having like a consensus of a shared space. That, let's say, if I'm viewing a street in VR, in AR with my phone, maybe I can see Tech who's in his VR goggles and he's there. So it should be a space where it doesn't matter what platform you're on. We are still in this shared space. And I think that's what the metaverse should be.
Yeah, agree. Totally agree on that. I mean, I think one last question before we close this Q&A. I think there is this also issue about like controversy, or like people worry about certain issue like health issue or like a social issue about the adoption of this new technology. Do you have any, let's say, points or arguments that can soothing the worry of the people that you can start adopting this, you can start take a benefit of this technological advancements, and what kind of things do you want to share to the audience that they still like feel worried or afraid to use, let's say, AR or VR technology? Anyone can?
So the social, both the social and health things are actually really interesting, because if you think about the social aspect, right? The stereotypical view has always been like, hey, you put on a headset and or you sort of disappear into your gaming world and blah blah blah.
Yeah.
Our parents always told us, right?
Yeah.
Stop playing your games, go out and get in here.
Yeah.
But these past 2 years have actually been really interesting, sort of showcase for that, right? Where you can't get out, right? Or and you're now reconnecting, whether it's just on Facebook or email, or you're in a virtual space with friends, right? Zoom or in VR, kind of reconnecting. So I've actually I've actually spoken to people who said like I've actually gotten more social time like in my headset than I have like going out to bars or something. So that's kind of interesting, and it also kind of, I would say, in a way it sort of gives you a safer space to interact with others, right? Both physically and I guess with things like Horizon and other things where you get that virtual sort of like safe space bubble, right? You can just like, I don't want to see anybody, right? And just like virtually shut yourself out. So I think that's actually really interesting on the social aspect. And on the fitness aspect, I've actually been doing a bunch of like fitness stuff on my headset, and it's been actually really interesting, like relatively compelling. It doesn't get me out running, but I don't like running anyway. But it gets me. I do a surprising amount of cardio, right? Just from this headset, which is it's surprising, right? Like getting a VR headset and like getting fit from that, right? It sounds kind of weird, but it's really it's something, right?
Yeah.
Yeah. At the end of the day, VR or AR is just a tool, right? Just like your mobile phone, there are societal, sociological concerns and health concerns. Like you're always constantly looking at it. I know pretty much everyone in the world is probably looking at their phones for at least 30 minutes to an hour after they say, I'm going to sleep. And it's just in a dark room, just like burning out their eyeballs before they're going to sleep. So no one's talking about that. But in the end, it's just a tool, and you use it to communicate, and it has benefits, and as well as a gateway to be addicted to games or applications that might not be so beneficial to you. So it's really up to the users and how we use it.
Yeah. Okay, then. So thank you so much. I think I still have lots of questions in mind, but I'm afraid that the time is very, very limited for us to discuss more about this. So thank you so much, Mr. Shawn, Mr. Teck, for your wonderful explanation and very, thought-provoking Q&A sessions. Thank you so much for everything. So I will give back to Miss Hani to continue the webinar. Yeah, I pass over to Miss Hani.
All right, thank you, Antovany, Shawn, and Teck, for that very insightful Q&A session. I know the audience might still be curious about this topic, as it is a lot to dive into, so I'm sure they can reach out through the contact addresses shared during the slides just now. So now, as we come to the conclusion of this event, I will be giving the mic to Yang Mulia Muhammad Nuril bin Haji Zaini from AITI for this event's closing remarks.
Thank you to our speakers, Shawn Beck and Teck Lee Tan, for the informative and insightful session today. And also thanks to our moderator, Antovany Reza. All of our speakers have acknowledged that the immersive technologies such as AR and VR is a unique instrument to adopt digitally into any enterprises. In this way, the use of reality, virtuality technologies allows consumers to have a more dynamic and autonomous role in their experience, leading to higher perception of value. Again, thank you to all, and your participation is very much appreciated. I hope everyone was able to have some fruitful takeaways that will be applicable for your business or organization. Last but not least, stay safe, stay healthy, and keep social distancing. Now I shall pass the floor to our facilitator, Hani. Thank you.
Thank you, Yang Mulia Muhammad Nur Ilham, for your speech. So as everyone answers the feedback form, we have come to the end of the seminar, Alhamdulillah. Thank you again to AITI for this opportunity to expand our knowledge on immersive technologies, and also to our esteemed speakers, Shawn Beck and Teck, for being so kind to share your insights on the industry. With that, Assalamualaikum warahmatullahi wabarakatuh, and have a great day.